All right, so after the introduction to the sine function, sine, cosine, and tangent, we come back and we talk about inverse trigonometric ratios. Because we're going to be interested in finding the measure of angles, and so there's a relationship here between, as I said before, between the angle and the ratios of the sides. So we can actually work backwards and find out the measure of the angle. If you knew the measure of the angle like we did in some of the previous stuff, then you can use that to find a missing side. Well, if you know the sides, you can find the missing angle. And that's where these inverse trigonometric ratios come from. Again, if you've got a calculator and you're looking at it, whether it's in a real calculator or a tablet or whatever, you'll see at the sine function, cosine, and tangent, there's a little second function up above it. So you push like the blue button on our calculators and push the sine, and you have the inverse of sine. And it's got this little notation that you can see there where it's got sine to the -1. That's what it looks like. It reminds you of the inverse notation in Algebra 2 when we had inverse functions. So we had that like f, remember how we had f of x, x the little negative, it meant inverse of the function of x. So we have these things here, and we're going to apply them, sine, cosine, and tangent. So let's look at this problem. It says use a calculator to find the measure of angle P. So this is the angle we're concerned about. It's important to get that nailed down first thing. And they want us to round to the nearest tenth, so that's what we're going to do. You'll notice in this problem that they've given us two sides. They did not give us this side. We could find that side because we know the Pythagorean theorem here, and when you have a right triangle and you know two legs or two sides, you can find the third side. So we could do this, but we really don't need to because that's not the question. The question is, what's the measure of the angle? So, observation tells us that according to this angle, this is the hypotenuse, this is the adjacent side. Do you agree with that as you look at it and you think about it? That's the opposite side, we don't care. This is the hypotenuse, this is the adjacent side. When you look at your trig functions of sine, cosine, and tangent, orange horses always have orange ankles. This is the one we're going to be working with because that's what we have is the A and the H. The A and the H. So we're going to write ourselves an equation using this information. So the cosine of angle P, which we don't know its measure, is equal to adjacent, which is 13, divided by hypotenuse, which is 19. Okay, so now we have an equation. It's an algebraic equation, but more importantly, it's a trigonometric equation. Now, do you agree that when we solve equations, we want to isolate the variable? In our case, the variable is p. You're going to get p by itself. If you want to get p by itself, you've got to get rid of the cosine. So in a way, you're dividing by cosine. So you can sort of see why that little -1 thing shows up there. We just call it the inverse. So it's simply that. P is equal to the inverse cosine of 13/19. That's what it's going to be. And that's how you're going to type it in the calculator. You're going to push that little second function, push cosine, which is actually going to give you the second function, which is the inverse of cosine. Type in 13/19 as a fraction probably. Certainly capture in parentheses if you don't put it actually as a physical fraction. Push enter and you will get some thing. You can see they did the same thing there. They're talking about doing the inverse cosine of 13/19 is what we said. Push the second function for cosine 13, put it in parentheses. You see how they did that. And they got this 46.8, so on and so on. They rounded to your nearest tenth, 46.8. So you need to do that. Pause the video, punch the buttons, do what you got to do. Just to kind of help us set another one up, this is D, looking for angle D. And you can see in this problem, they've given us the hypotenuse and the adjacent. So that's another one of those cosine problems. We'd set it up the same way. We would say the cosine of D is equal to adjacent, which is 23, divided by hypotenuse. Adjacent. Well, you can see I messed that up really, really bad. This is the hypotenuse. This is the opposite sign, so it's not cosine at all. Yay, I caught myself. But I didn't leave that in the video forever and ever, amen. So it's the sine, isn't it? So the sine of angle D is equal to, remember, orange horses. So it's the opposite, which is 16 divided by the hypotenuse is 23. So in other words, D is equal to the inverse sine of 16/23. So you pop that in a calculator, round to the nearest tenth, and you find out the answer is 44.1. So we could go on and on with that. This one's rounded to the nearest hundred. It says solve the right triangle. So this is very, very big. Again, it's something you're going to see a lot of in your pre-cal. Solve the right triangle. Now, when they say solve the right triangle, they're saying we want to know everything. We don't know everything. We want to know all angles and all sides. Well, they've given us two sides. We just got to find the third one. Then we'd know all three sides. They've given us one angle. If we find one more, then we can easily find the other one, and it would be done. But it's going to take a little work to do that. First of all, just deal with the sides. If we want to find the third side, which happens to be the hypotenuse, in a right triangle, and we know two legs or two sides, it's easy to find the third side using Pythagorean theorem. So we'd use Pythagorean theorem to find that third side. I'm not going to do that because we've done it so much, but that's what you do. And then you'd know the third side. Just round the side measures to the nearest hundredth. That's what they want us to do. The angle measures to the nearest degree. So we got to pick one. We're either going to find A first or find B first. It doesn't kind of matter. Since I'm sitting here, I'll just do the A first. So this is the opposite side, and this is the adjacent side, and this is the hypotenuse, which I don't care about, right? Doesn't matter at this point. I'm not going to deal with that. So opposite and adjacent happens to be tangent. So the tangent of angle A, remember orange horses always have orange ankles, so that's 4 divided by 7. So that means A is equal to the inverse tangent of 4/7. Okay, the inverse tangent of 4/7. Now, I don't have a calculator here. I could go there and get one, but I'm just going to say. So you put it in here and you round, okay? I'm going to pretend for a second, just for a second, I'm going to pretend that this is 40 degrees. I don't think it is, but I'm going to pretend it's 40 degrees. If that's 40 degrees, then that's 50. If that's 30 degrees, then that's 60. If that's 43 degrees, then that's 47 degrees, because they got to add up to 90, because the 90 here, the 90 there makes 180. So whatever this is, whatever it is, once you find that one to the nearest whole degree, then it's easy to find the other one. Let's see what they've got here. So they did their 30. That's what they got. So if that's true, if this is 30 right here, then this is 60. And that's how that would work. So now, although I didn't find the hypotenuse with the Pythagorean, I could have easily done that and would have known that pretty quick. And so that's what you do when you're, see there's the Pythagorean, and they round to the nearest hundredth. And we could do that more and more, but that's pretty cool how you can do that. But anytime you see this language that says solve the right triangle, that's what they want to know, everything. All three angles, all three sides. They've given us two sides and one angle, so we've only got 3 missing pieces because there's 6 things, 3 angles, 3 sides. So they've given us 3 pieces, 2 legs and a right angle. So it wouldn't be too hard to find the others.